Righto, Year 12, I'm going to go through trigonometric substitutions via a video. It's not the way that I really wanted to do it, but we'll see how this goes, and maybe you might like it. Maybe it might be a way to do some of the lessons in the future. But anyway, let's have a look. So trigonometric substitutions. We're going to look at our integrations when we come across things like root a squared plus x squared and root a squared minus x squared and root x squared minus a squared. So when you see some of these, you're going to have to think to yourself, well, what am I going to do? If I'm doing the first one, I want you to think to yourself, all right, I'm going to use x equals a tan theta. And when it's a squared minus x squared, I'm going to use x equals a sine theta, or x equals a cos theta. You'll see pretty soon how you can work these out. When it's x squared minus a squared, we're going to use x equals a sec theta. All right. So the easiest way, so you put that, you put that information so that you can see it every day somewhere in your bathroom, near your mirror, on your wall, so that you know, all right, when I see that, that's what I'm going to use. All right, so let's go to an example. And we'll take Patel's first example, example 1, which is the integral of dx on root a squared plus x squared. Now, what we're going to do, we're going to let, well, what do we got? Root a squared plus, so we're going to use tan. We're going to let x equal a tan theta. Now, the first thing you do is differentiate. Dx to theta equals a sec squared theta. So dx equals a sec squared theta d theta. Now remember, you get that from your reference sheet. You can just look at the integral of sec and see that it equals tan, so the derivative of tan is sec. And I've got that right in front of me here. The integral of sec squared is tan. Now what we do is we're going to draw a little triangle to illustrate how we're going to use this. So we go down here. And if we've got x equals a tan theta, that means tan theta equals x on a. So I can put them in and look what I get, a squared plus x squared all square rooted, which is what we're trying to integrate. So when you're trying to think, oh, what do I use? If you pick the wrong one, you'll end up with the wrong equation. So if I'd picked sine, I would have ended up with the wrong thing. And you'll see when we do one of the sine ones how it works out. Okay, so let's put in the things that we've now substituted. Our integral is now, or dx, here's dx. Our integral is a sec squared theta d theta. And what have I got down the bottom here? I've got a squared, square root of a squared plus x squared. Well, we'll just leave that, and we'll get the square root of a squared. But x squared, we're going to use this thing here and square all that. Work it out. So we're going to get plus a squared tan squared theta. Okay, let's continue this on down here. I've got the integral of a sec squared theta d theta. And underneath, well, I'll take that a squared out, and you can see what's going to happen. I'm going to factorise that a squared out in that underneath that radical. I'm going to get 1 plus tan squared theta. All right, well, now the square root of a squared, this bit here, because it's factorised, I can take that out. So I'm going to get the integral of a sec squared theta. Just put that d theta at the back there now. And I've got a on the square root of 1 plus tan squared theta. But what is 1 plus tan squared? It equals sec squared theta. Now, that'll give me, the a's will cancel. They're a constant. And I'm left with sec squared theta on sec theta, because the square root. And because that was, we only take the positive because there was no plus and minus way back here. There was no plus or minus there, so we don't need to worry about plus or minus, or the negative. And that'll give us this integral of sec theta d theta. Now, I'm going to do the integral of sec theta over here, just in case you forgot how we did it. So, well, I might do it over here. So, I'll just make this whole thing bigger. So, the integral of sec theta. Now, we've done this before, so if you've seen that, you know this. If you know this, you can just fast forward. But I want to go over it because you need to have this as a must-have. Okay, well, we know that if y equals tan x plus sec x, well then dy dx equals, well, the derivative of tan x is sec squared x, and the derivative of sec x is sec x tan x. And that's going to become useful in a minute. Let's go back to this. Well, the integral of sec x. Well, this is not intuitive, but we're going to multiply sec x. We're going to multiply top and bottom by the same thing, so we're not going to change anything. So we're going to multiply by sec x plus tan x on sec x plus tan x dx. And what do we get? Well, on the top, we get sec squared x plus sec x tan x dx all over sec x plus tan x. And wow, look at that. We've got the derivative on the top of the function underneath. So when I integrate that, I get ln of sec x plus tan x plus some constant. Now, you need to know that. You need to remember that the integral of sec x dx equals that. So just put that somewhere. Again, on your bathroom mirror, or somewhere where you see it quite regularly. If you see it all the time, you'll remember it. You'll remember what it is and where it comes from. So somewhere where you brush your teeth every day, or above your study desk, or in the bathroom, anywhere. So now, if we go back to this one, here we go. That's ln of sec x plus tan x plus some constant. And you think to yourself, great, I'm done. Well, not quite yet. Because we're still in theta, sorry. We're still in theta. So we have to replace. We have to replace it. Now, up here, we've got theta. See that little diagram we did earlier? So when we go here, we can refer back to this point. Say, all right, well, sec x. Well, sec x is the reciprocal of cos, and cos is a on root a squared plus x squared. So it's just ln, the reciprocal of that. So it's root a squared plus x squared on a plus tan, well, that's x on a. And luckily, we have a common denominator, and our common denominator is a. So we get ln root a squared plus x squared plus x on a plus c. Now remember our log laws. That then just becomes a subtraction. So ln root a squared plus x squared plus x minus ln a plus a constant. And we'll just write that the way that Patel does, which is x plus root, he likes to put the x's first, x squared plus a squared minus. Now, that is just a constant. So we'll call this k. We can call it C2 if you want. And there we go. There's the first example. Let's have another go at the second one. So, example number 2. And there it all is, in all its glory. Just in case you want to have a quick look at it. Remember the things you need to put up on your bathroom wall. That integral of sec x, and the first 3 things that we did up here. Okay. Let's have a go at the second example. Example number 2. We're going to integrate dx over root x squared minus a squared. Now, what did it say? Remember, if you get it wrong, it doesn't matter. You'll just do some work and get down to the point where, oh, I've used the wrong one when you draw your triangle. So we've got to use a sec. Here it is. That one. A sec theta. So let x equal a sec theta. Dx d theta, I'm going to do this on one line this time, is a sec theta tan theta d theta. You should know that by now. You know you can do that by doing the quotient rule, writing it as a fraction as 1 over cos and doing the bottom times the derivative of the top minus the top times the root. Okay, you'll work it out. Now, let's put that in, and I get a sec theta tan theta d theta. And on the bottom, I get this squared. Yes? So be aware that's what I'm doing. I get a squared sec squared theta minus a squared. Okay. Tidy this up. And I get, and you can see what's going to happen. The a is going to cancel, isn't it? So I get a sec theta tan theta. And underneath, I get a squared outside of sec squared theta minus 1 d theta. And I get a sec theta tan theta d theta. And on the bottom, I get a, now this sec squared theta, well, I'll do it, a squared. Sec squared theta minus 1 is tan squared theta. And you're already thinking, so you're probably moving ahead in the video, a sec theta tan theta over a tan theta when I square root that, d theta. Do a bit of cancelling. There goes my tan, there goes my a. Oh, and look at what I've got. I've got the integral of sec theta again. That's come up again. Make sure you have that little thing rule we learned last time. Okay, we'll go back here. We'll draw our triangle now. And what did we do? We went a sec theta. So if we put theta here and we draw our triangle and we realise that sec is the reciprocal of cos. So if I rewrite this, this is going to be sec theta equals x over a. So this is going to be a and this is going to be x because it's a reciprocal of cos. Here's my right angled triangle and I do my Pythagoras and I get x squared minus a squared there. So I'm away now because now I can write sec theta, or here we go, we get this tan theta is going to equal root x squared minus a squared over a, to get it back. So let's see what we get here when we do this integral. All right, so we know that's going to give us ln of sec theta plus tan theta plus some constant. Now sec theta, we already know, is x on a. So we get ln x on a when we substitute it back. And tan theta is root x squared minus a squared on a. And again, we've got a common denominator, which is fantastic because we're going to get rid of that ln a because we're going to get ln x plus root x squared minus a squared on a plus some constant. Now I can take that ln a out. So I've got ln of x plus root x squared minus a squared minus ln a plus c, and again we're going to just call that a big constant k. And there's my solution, ln x plus root x squared minus a squared plus some constant k. Beautiful. Well, one to go. One to go? I think that's it. I might do... so now what I want you to do is, using this methodology, is go and have a go at exercise 2C, questions 7, 8, 9, 11, 13, 15, 17, and 19. Yeah, that's it. So there are your three, which you've got to know what to do. I'm just looking ahead and seeing if there's a tan one in there. And we already done a tan one. And the second example, what did we use? X equal a sec. I'm going to do question 7, or kickstart you off on question 7. Let's have a look. So here we go. Let's have a go at question 7. So here's 7. What have I got to do? I've got the integral of the square root of a squared minus x squared dx. And what did my thing tell me when I've got a squared minus x squared? I can use sine or cos. So I'm going to use sine. And remember, that little group of 3, you need to have that put up somewhere. So I'm going to let x equal a sine theta. Therefore, dx equals, let's do my little thing here, sine cos, negative, negative. The derivative of sine is cos, so I'm just going to get a cos theta. And that's why you tend to pick sine, because if you get cos, you're going to have a negative, and that's d theta. So here we go, equals the integral of a squared minus, now, better do this, if x equals a sine theta, x squared equals a squared sine squared theta. And dx is a cos theta d theta. All right, integral, well, we'll factorise that a out, so we get a squared 1 minus sine squared theta. And you're thinking to yourself, you beauty, I'm going to get cos out of that, times a cos theta d theta. And that's going to give me the integral of a squared cos squared theta times, thought I was using the thick pen, times a cos theta d theta, which equals the integral of a cos theta times a cos theta d theta. Well, that's great. That means I can get that a times a is a squared. I'm taking that out the front. I get cos squared theta d theta. Now I know what cos squared theta is. We've done that before. That gives me a squared, and I'll get a half theta plus sine 2 theta over 2 plus some constant. And that'll give me a squared theta on 2 plus a squared sine 2 theta on 4 plus c. Alright, let's go back up here, draw our triangle. Remember, if x equals a, sine theta equals x on a. So I put theta here. That's where I'm getting this from. Sine theta equals x on a. So there's x, there's a, and this is the square root of a squared minus x squared, which is what we wanted. See, up the top there, the very beginning integral. Now, sine theta equals x on a. Theta equals inverse sine of x on a. Okay, so what do we do here? And sine 2 theta equals sine theta plus theta. I'm using our double angle. Will give us sine theta cos theta plus sine theta or cos theta sine theta, which gives us 2 sine theta cos theta. So let's go back to our integration. We've got a squared on 2, so a squared on 2. Now theta, well, that's inverse sine. Now we shouldn't be worried or afraid of using this. That's just an integral, x on a, plus a squared on 4 sine 2 theta. Well, that's 2 sine theta cos theta, and we've still got this constant. So we get equals a squared on 2. We're not going to be doing anything with that, x on a, because we already got that in the x's, which is what we want. It's not equals, it's plus. Plus 2 goes into this. I've only got 2 on the bottom. So you get a squared on 2. Now sine theta. What was sine theta? X on a. So you get x on a. What's cos theta? Root a squared minus x squared on a. Root a squared minus x squared on a plus the constant. And we're just about right now. I could factorise out the a squared on 2, but if you look over here, that a squared is going to cancel with these two a's here. So I'm going to get a squared on 2 inverse sine x on a plus x on 2 square root a squared minus x squared plus c, which is your answer. So that's trigonometric substitutions. We're using substitutions to get them in a trig ratio so that we can integrate them, and then we substitute it back. And we're just using a right angled triangle to do it. So what are your keys again? Your keys are back here, and realising, well, what am I going to use? If I've got a plus square root, I use tan. If I've got a constant minus x squared, I'm going to use sine or cos. I usually go for sine because you get rid of the negative. And when you've got x squared minus a, you're going for sec. Remember, you do have to know this over here. The integral of sec x dx is ln sec x plus tan x plus c, which we've done before, and all your other trig work. Anyway, good luck with that. And 2E, questions 7, 8, 9, 11, 13, 15, 17, 19. Good luck.